right, let's take a look at this example. So we're given a polynomial function where b is an unknown real number. Okay, so here's our polynomial, and notice, yep, there we have it. There's a b where there should be a number, right? Because we have exponent in this one is x. So, excuse me, the variable in this one is x. So we know this b is probably out of place. We want to know what that number should be. It says if x plus 3 is a factor of this polynomial, then what is the value of b? There's two different ways that we can solve this. Okay, we're going off the fact that we know if it's a factor, the remainder when we divide it into this will be 0. Okay, but the remainder theorem also tells us that if we do synthetic division and get a remainder of 0, that is a factor. And we also know that that's the same as if we plug this value into the polynomial. So there are two different ways you can do this, and I know right now you're going, that makes no sense, but I'll show you both ways and then you can select which one works best for you. I'll start with the method using synthetic division. Okay, so with synthetic division, again, the first thing you check is your polynomial. Make sure the terms are in order. I have a fourth power, third power, second power, first power, and a constant. They are in order and nothing was missing. Write down the coefficients for those. So we have 2, 9, b, -9, and -9. On the outside, we write what we're dividing by. In this case, the factor is x plus 3. To find out what you're dividing by or what that 0 would be, you set it equal to 0 and solve. We are dividing by -3. Okay. Now we do our synthetic division, so we drop the first number straight down and we multiply. -3 times 2 is -6. Then we add 9 plus -6 is a positive 3. And we multiply. -3 times 3 is -9, and we write that under our next number. Then we add b plus -9. Those are not like terms, so we cannot combine them. All we can do is write them as b minus 9. We multiply -3 times b minus 9. We take the -3 times each part. -3 times b is a -3b, and -3 times -9 is a positive 27. And then we add. Now, -9 and 27 are like terms, so I can go ahead and add those together. -9 plus 27 is 18, so I have -3b plus 18. And we multiply. -3 times -3b is a positive 9b, and -3 times positive 18 is a -54. And then we add -9 plus -54. Okay, the 9b I can't combine with anything, but -9 plus -54 gives me -63. Now, what did that do for me besides give me what looks like a mess? We know, because of the remainder theorem, that if x plus 3 is a factor of this polynomial, the remainder, which is this term on the end, should be 0. So we know that this value should be equal to 0. And we can take 9b minus 63, set it equal to 0, and solve to find out what b should have been. Okay, so we just solve this equation. Add 63 to both sides. We get 9b equals 63, and we would have to divide both sides by 9. And we get that b is 7. So we know in this polynomial, b should have been a 7. Okay, so that's the first method you can use here. You can use synthetic division. The other method you can use is to just substitute this value in. Once again, if this is a factor, okay, we know that it's a solution to this being equal to 0. So we know that 0 equals, and again, if x plus 3 is a factor, you're substituting in -3. We know that when we put -3 into this, we should get 0 because it is a factor. Okay. So this is the other option. You can put -3 straight into the polynomial and set that equal to 0 and solve. Okay, so replace all of the x's with a -3. That gives me b times -3 squared minus 9 times negative 3 minus 9. I just took this polynomial, replaced every x with a negative 3, just like we would do if we were trying to evaluate when x is negative 3. Okay? Well, negative 3 to the fourth is a positive 81. Negative 3 to the third is a negative 27. Negative 3 squared is a positive 9. Negative 9 times negative 3 is 27. And then we have minus 9. I'm just going one step at a time so we don't leave anything out. 2 times 81 gives me 162. 9 times negative 27 is negative 243 plus 9b plus 27 minus 9. Now notice I have a b here, but all of these other terms are just numbers. So I can combine them. I can do 162 minus 243 plus 27 minus 9 to get a single number. And when I do that, that single number is negative 63. So I have 9b minus 63 equals 0, and once again I'm just solving that to find out what b is. And again, this comes from the fact that if x plus 3 is a factor, then negative 3, when you put it into the polynomial, should give you 0. So we know negative 3 plugged in should equal 0, and so we are just solving to see what b would have to be for that to be the case. And once again, we get 63 equals 9b, and when you divide both sides by 9, sorry, those look pretty bad for 9s, I get b is 7. Okay, so this is two different options for solving. Whichever you're most comfortable with, I would go with. If it's a long polynomial, sometimes synthetic division is quite a bit faster. Okay, I'm going to do one more of those. Okay, and if you would like to pause, try it on your own and then push play to check your answer, that's just fine. Or if you just want to follow along. This time we're given the polynomial x to the fourth minus 2x to the third minus 13x squared plus kx minus 24, and we know that x minus 3 is a factor, and they want to know what number should go here in the place of k. So let's try that out. I'm going to do synthetic division method first. Okay. Again, double check. Okay, we have a fourth, third, squared, first power, constant. Everything is there. Write down the coefficients. Well, this would be a 1, x to the fourth, negative 2, x third, negative 13 for my x squared, k, x, and negative 24. We're dividing by x minus 3, which means we put a positive 3 here. Again, that comes from if you're dividing by x minus 3, the 0, so we set it equal to 0 and solve, would be 3. So that's what we're dividing by. We do our synthetic division. So we drop the first one straight down and multiply. 3 times 1 is 3. Negative 2 plus 3 is 1. 3 times 1 is 3. Negative 13 plus 3 is negative 10. 3 times negative 10 is negative 30. Again, we cannot combine these. All we can do is write them as k minus 30. Then we multiply. 3 times k is a 3k, and 3 times negative 30 is negative 90. And here we go ahead and add. That gives me 3k, and negative 24 plus negative 90 gives me negative 114. Again, from here we know that if x minus 3 was a factor, this value right here should be 0. It happens every time. If it's a factor, the remainder, or the last term in synthetic division, should be 0. So we know that 3k minus 114 should equal 0. And if we solve that, we'll know what k was supposed to be. I would add 114 to both sides. Gives me 3k equals 114, and we divide both sides by 3. Okay, so if we take 114 and divide it by 3, we get 38. So we know that k should have been 38. All right, so synthetic division, if that's your method, you're done. If you prefer the other method, I'll show you what that would look like as well. We're going to get the same answer, but I'll go through both. Again, x minus 3 is a factor, so we're putting in 3. So replace every single x with a 3. So that gives me 3 to the 4th minus 2 times 3 to the 3rd minus 13 times 3 squared plus k times 3 minus 24. And then we just go through and try to simplify this. So 3 to the 4th is 81. That's 3 times 3 times 3 times 3 minus 2 times 3 to the 3rd, which is 27, minus 13 times 3 squared, which is 9, plus, I'll just write this as 3k, that's the way we're used to seeing them, is with the variable second, and minus 24. Simplify a bit more, so negative 2 times 27 is a negative 54, and negative 13 times 9 is a negative 117, plus 3k minus 24. Again, we know that this should equal, I'll put this over here, should equal 0. Okay, that's what it means to be a factor. When you substitute the value in, you get 0. All right, so let's combine terms. So 81 minus 54 minus 117 minus 24. Let's put all of those together, and when I do, I get negative 114. So I have 3k minus 114 equals 0, and we're solving the same equation we did on the other side. So I add 114, which gives me 3k equals 114, and I divide both sides by 3. And I get x is 38. Okay, so whichever method you're most comfortable with, either of them work. It's up to you.